Do you guys know what is geometry? Today, our group going to present about geometry. Our group consists of 4 members starting from me, Nur Alia Maisara binti Ahmad Shamsuddin.
Hi, my name is Nur Arisha Sofia binti Sahariza.
Hello, my name is Nur Aisyah Maisarah binti Rashidi.
Hello, my name is Intan Nazira binti Muhammad Nazri. So what is geometry? Geometry is the study of the characteristics, measurement, and connections of points, lines, angles, surface, and solids. Besides that, it is the apex of abstract logical thinking where every result can be proven. And the most important thing is geometry is aspects the ability to produce accurate drawings. Hello everyone, so I am here to tell you guys about the Louvre Museum. So what is Louvre Museum? The Louvre Museum is the museum that houses an enormous collection of art history and cultural objects, especially like the famous works by Leonardo da Vinci, which is Mona Lisa, Venice de Milo, and Winged Victory of Samothrace. Um, the Louvre Museum is the modern glass pyramid. Entrance is designed by architect L.M. Pei, and over 35,000 artwork on display spanning ancient civilization to the 19th. Besides that, the Louvre Museum itself has their own history. So, during the 12th century, the Louvre Museum began as a fortress built by King Philip to protect Paris from invasions, especially from north. After that, during 16th century, King Francis I demolished much of the fortress and transformed the Louvre into a Renaissance royal palace. During the 1682, King Louis moved the royal court to Versailles, and the Louvre became a palace to store royal art. And after that, in the 18th century, after the French Revolution, the Louvre started to open as a public museum. And by 1989, the famous glass pyramid was added as the main entrance designed by architect L.M. Pei and be the Louvre Museum until now.
Application of geometry in glass pyramid at Louvre Museum. Problem statement. Given a pyramid square base EV is 34 meter and the height is 21.6 meter. Given O is the midpoint of EV. Question 1. Find the volume of the pyramid. Question 2. Find the angle of AEO.
Calculation for question 1. First, recall the formula for the volume of a pyramid. The formula is volume equal 1 over 3 times base area times height. So, to find the volume, we need the area of the base and the height. The base and the height already been given. So, we need to find the area of the base. The base is a square and each side is 34 meters. To find the base area, we multiply 34 meters times 34 meters equal 1156 square meters. After that, we substitute all values into the formula. Volume equal 1 over 3 times 1156 times 21.6. Now, we calculate step by step. First, 1156 times 21.6 equal 24,969.6. Then, we divide by 3. 24,969.6 divided by 3 equal 8,323.2. Therefore, the volume of the pyramid is 3,023.2 cubic meter. Calculation question 2. Find angle AEO. Step 1. Identify the right angle triangle. First, we look at triangle AEO. At point O, there is a right angle. So triangle AEO is a right angle triangle. The angle I want to find is at E. So we will use trigonometry on this triangle. Step 2. We find the length of EO. Before using trigonometry, we must find the length EO. From the diagram, the full base E to B is 34 meters. Point O is the midpoint of the base. So we say EO equal 34 divided by 2, which is 17 meters. Now, to find the diagonal EO in the smaller triangle, we use Pythagoras theorem. We say EO equal the square root of 17 squared plus 17 squared. That is written as EO equals square root of open bracket 17 squared plus 17 squared close bracket. 17 squared is 289. So EO equals square root of 289 plus 289. That gives EO equals square root of 578, which is also 17 square root of 2. EO is approximately 24.0416 meter. Step 3. Choose the correct trigonometric ratio. Now we focus on angle theta at point E. The opposite side is AO, which is 21 meters. The adjacent side is EO, which is 24.0416 meters. Since I have opposite and adjacent, I use tangent. We say tangent theta equal opposite divided by adjacent, written as tan theta equal 21 divided by 24.0416. Step 4. We apply inverse tangent. To find the angle, I use tan inverse. We say theta equal tan inverse of open bracket 21 divided by 24.0416 close bracket. After calculating, theta equal 41.1368 degrees. The final answer is the value of angle AEO is 41.1368 degrees.
This is the history of Baskin-Robbins. Baskin-Robbins started in 1945 in the United States. It was created by Bert Baskin and Irv Robbins. The ice cream shop became famous for offering 31 flavors, meaning the different flavor for every day of the month. Today, Baskin-Robbins is popular all over the world for its many ice cream flavors. What is the shape of ice cream cone? An ice cream cone is primarily a conical shape with a circular opening that tapers to the point. Flowers designed to hold ice cream. While many feature this a traditional pointed, like 3D triangle structure, they also come in flat bottom and cup-like shape. Application of geometry in ice cream. Problem statement. First, a famous ice cream shop named Baskin-Robbins created a new recipe for their cone ice cream to attract more customers. The new recipe is they put a chocolate sauce at the bottom of the cone. If the radius and height of the cone is 3 cm and 14 cm respectively, and the volume for the chocolate sauce is 5 cm square, find remaining volume of the cone. Second, when the ice cream with sphere shape is scooped to the cone, there is a small portion of ice cream that goes into the cone. Find the area of the shaded region if the radius of the sphere is 4 cm. Third, one day a man came to the shop to buy 50 cone ice cream, but he wanted a hemisphere shape of ice cream. If one cone only costs Rm 2 ringgit and one scoop of sphere ice cream costs Rm 4 ringgit, find the cost of 50 cone hemisphere ice cream that the man has to pay.
Okay, first question. Find the remaining
volume of the cone. So we use formula volume of a cone, which is 1/3 pi r square h. And we insert the info given into the formula, so 1/3 times pi times 3 square times 14. And use calculator to calculate, and the answer we got is 42 cubic centimeter. And then we have to find the remaining volume of the cone. Use 131.9469 minus 5 equals to 126.9469 cubic centimeter. Okay, next question. We have to find the area of the shaded region if the radius given of sphere is 4 cm. So first thing first, we have to find the surface area of the sphere using formula 4 pi r square. So you insert the information given to the formula. So 4 times pi times 4 square equals to 64 square, or 201.0619. Next, we have to find the surface area of an enclosed cone using the formula S pi r. So first we need to find the S, which is length height, using the theorem Pythagoras formula. So square root 14 square plus 3 square equals to square root 205, or 14.3178. That's the length height we got. And then we insert the information that we got to the surface area formula. So square root 205 times pi times 3 equals to 134.9423 square centimeter. And then lastly, we have to search for the area of shaded region. We use the formula that we create, which is 4 pi r square minus S pi r. So 201.0619 minus 134.9423 equals to 66.1196 square centimeter. Okay, and the last question, we have to find the cost of 50 cone hemisphere ice cream that the man has to pay. So we know that one scoop of ice cream equals to 4 ringgit. So first we need to find the surface area of the hemisphere using the formula 3 pi r square. So we insert the information given to the formula. So 3 pi 4 square equals to 48 pi, or 150.7964 square centimeter. So we need to find the cost of each hemisphere ice cream with the ratio formula. So cost of each hemisphere ice cream divided by 4 equals to 48 pi divided by 201.0619. So we calculate using calculator. We got each of the hemisphere ice cream is 3 ringgit. Lastly, we can find the cost of 50 ice cream cone that the man have to pay. So 2 times 50 plus 3 times 50 equals to 250 ringgit. Okay, in conclusion, geometry is deeply woven into our daily lives, often without us even noticing. From designing buildings, roads, and bridges to arranging furniture, creating arts, and using technology, geometry is not just a classroom subject. It is a practical tool that helps us understand, organize, and improve the world around us every day.